everything is factorable. Is everything factorable nicely?
No.
No. So this is factorable. Is it factorable nicely? No. So in this case, we're going to complete the square. We're going to move the 7 over. Is that allowed if we wanted to? Sure. And now what we're going to do is we're going to add the same thing to both sides. As long as you add the same thing to both sides, is it still a true equation? Do you remember what we added to both sides? Anybody remember? We added the same thing. It was b over 2. What was the b value here? What's the b value right there?
5.
Yeah, the 5. So we're going to add 5 over 2 squared to both sides. Now, did I just add the same thing to both sides? So is it still true? Yeah. What's the reason we did? Now, theoretically, could I add pi to both sides? Sure. Is that going to help us? Not really. We added this number because it creates a square for us on the left. Does anybody remember what it creates here? X plus something squared. Anybody remember? It's right there in front of you, actually. It's
5 over 2.
It's just plus 5 over 2, like that. What's really cool about it? And we can test that out. How do we test that out if we really wanted to test that work?
How much you say you got 5 over 2?
I'll show you. How we get 5 over 2?
Yeah.
You do half of that value right there. Whatever that value is, you do half of it squared. It's just a method. And the reason it works is, take a look. X plus 5 over 2 times x plus 5 over 2. If we wanted to test this, we have to FOIL it, right? What's x times x, Kelly?
Squared.
Then you get 5 over 2x plus 5 over 2x plus what? 5 over 2 squared, right? What's 5 over 2 plus 5 over 2? What's half of 5 plus half of 5? 5. So this turns into x squared plus 5x plus 5 over 2 squared. Is that exactly what we wanted it to be? Yes, it is. The reason we did this is, how do you get rid of a square right here? What do you do to get rid of that square? What do you do? Well, no, we want to get rid of it. We don't want to expand it. We square root both sides. And if we square root both sides, we end up with x plus 5 over 2 equals plus or minus the square root of this thing. I just haven't added the fractions together. Why did I do plus or minus?
It's a square root.
You added in a square root, exactly. If I ask you what number times itself equals 9, you say 3 or negative 3. If the square root is already there, you don't add it in. Now, how many fourths are in 7? How many fourths are in 7? Oh, come on, kids. How many fourths? There's 28 of them, right? It's 28 over 4 plus 25 over 4. I'm just adding fractions here, everybody. How many fourths are in 1?
I was going to say 1 and 3/4.
Okay, there's a lot of other things you could say, but again, do you understand why there's 28 fourths in 7?
Okay.
28 divided
What's
by
4 times 7?
Oh, you meant it like that.
I did. Equals plus or minus the square root of 53 over 4, right? What do I need to get rid of now if I'm isolating x?
square root.
Well, no, we already have the square. We need to get negative 5 over 2 plus or minus the square root of 53 over 4. Now, is there anything we can do to simplify this thing right there?
Square.
You can change it to a what is it called? A compound fraction? Is that like a compound number?
Well, no. What can I do? Well, look, this is going to be plus or minus the square root of 53 over the square root of 4, right? What's the square root of 4?
2.
So this turns into negative 5 plus or minus the square root of 53 all over what? 2. That would be your final answer. Now, the thing is, theoretically, if you could, should you simplify the square root of 53? Yeah. Yes, but 53 is a prime, so no, you can't go anywhere with it. Now, this right here, the magical step. What was that magical step? Kelly, you asked about it. What was the magical step here? Yeah, getting this number, because once you get the 5 halves, everything else is just algebra. You have to be careful. Is it easy to make simple mistakes on this? Yes. The way you identify what you add to both sides, it's always b over 2 squared. It's always b over 2 squared. So you're going to help me walk. You're going to walk through this with me. Let's try. How about x squared plus 3x minus, let's say, 5 is equal to 0. Someone tell me, what should I do first on this one? Don't write it down, just watch. You can just tell me. Move the 5 over. So you have x squared plus 3x equals 5. And now we have to do what to both sides? We have to add or subtract something. We want to add something to both sides. The same thing.
3 over 2 squared.
Yeah, add 3 over 2 squared. Like this.
Yeah.
Let's clean it up a little bit. Well, this turns into x plus 3 over 2 squared is equal to 5 plus 9 over 4, which is 20 over 4 plus 9 over 4. So what do I end up with? X is equal to, well, x plus what? Sorry.
X plus 3
Over 2
squared.
Plus or minus the square root of what? 29 over 4. Oh, what's the square root of 4?
2.
2. So we end up with x is equal to negative 3 plus or minus the square root of 29 all over what?
2.
2. Can you simplify the square root of 29?
No.
No. You're done. So again, what was that magical step? What was that thing we did? The magical step was this thing right here, right? It works. Do you know where it comes from? Yeah, it's the b over 2 squared. So how about you try one of these on your own? Try solving this one for me. X squared minus 5x minus, let's say, 3 equals 0. Do that for me.
Move the 3 over the other side.
Yeah, that sounds good. And then after you've moved a 3 over, you need to add the same thing to both sides. What am I going to add to both sides? Negative 5 over 2 squared. Negative 5 over 2 squared. Because what does that then factor into? X minus 5 over 2 squared equals 3 plus 25 over 4. How many fourths are in 3?
12.
So it's 37 over 4. So what do you end up with? X minus 5 over 2 is equal to plus or minus square root of 37 over 4. But that's plus or minus the square root of 37 all over what? 2. So what do you end up with? X equals 5 plus or minus the square root of 37 all over 2. There it is. Nice. Now, is this kind of an annoying method? Absolutely. But is it pretty much the exact same work every time? Yeah, that's the saving grace. That's the same thing. What can you do? See what I mean? Yeah, sorry. I'll be more careful about skipping around. Okay, so here's the deal. Is it kind of annoying? Yes. Are you going to want to have to do this every time? No, but if you're totally stuck, is this a method you could use? Absolutely. So, I want to work our way through something that's really important. You do not have to memorize this. It's not going to be something I ask you on the test, but it's really important that you see it once. Do you understand? So all I want you to do right now is put down every writing utensil you have and just watch. Don't write any of this down. Put your tablets flat like they should be and just watch. This is the general quadratic right here. This is standard form. This could represent what type of quadratic? Any quadratic. This represents all quadratics. Are you okay with that? Any quadratic fits this form. Okay. So, if I wanted to complete the square on this, what's the nasty thing about this one? Not just A, B, and C. What's a little bit nasty about it? Which one, A, B, or C? Which one do you not like the most?
A.
You don't like the A, right? So if we wanted to get rid of the A, what could we divide everything by?
A.
You could divide by A, right? That does not change the solution. But if you divide by A, what do you end up with? X squared plus B over AX plus C over A equals 0, right? Because A over 0 is, sorry, 0 over A is 0. Now if I wanted to, could I rewrite it like this? B over AX equals negative C over A. Put it over on the other side. If I wanted to, right? Half of B over A is B over 2A. And you square it. So what am I doing right here? I'm just completing the square. Is it a little nasty? Yes. Is this something you're going to have to do on your own? No. The only thing I want you to be okay with is, are you okay with each algebraic step I take? Are you okay so far?
Yeah.
What's nice about this is that this right here turns into a square. X plus B over 2A squared. Over on the other side, it's a little bit not cool. But what do we like to do when we have fractions? To add or subtract fractions, what do we need to do? Common denominator. So let's work on the right a little bit. You have negative C over A. Let's multiply this with B squared over what? What's 2A times 2A? What's our common denominator going to be? 4A squared. So what do we need? We don't need to multiply this by anything, but what do we need to multiply this one by? Over 4a. So what does this become? Negative 4ac over 4a squared plus b squared over... Oh, do we have a common denominator now? So what do we have? And the only reason we did that is we didn't like having two fractions, right? Did we do anything to the right-hand side?
Yeah.
Not yet. Well, not yet. We will. We just brought that down. What are we trying to isolate? Are we trying to isolate A, B, C, or X? X. We always solve for X, pretty much. How do we get rid of a square? Yeah, we're completing the square. We're going to square root here. So we have X plus B over 2A is equal to this plus or minus the square root of this thing, right? Okay. What do we subtract on both sides? What do we subtract? So we have this thing, and I'm going to rearrange this a little bit. B squared minus 4ac all over 4a squared. I'm going to do a little bit of algebra on this to simplify it. This is the square root here, right? 4a squared. What's the square root of 4? What's the square root of a squared? So what is this? Negative b plus or minus over 2a plus or minus this thing right here all over. Oh, do we have a common denominator? X is equal to negative b plus or minus the square root of b squared minus 4ac all over. Has anybody seen this before?
Yeah.
This right here is called the quadratic formula. This is something you absolutely have to memorize and know cold. And you have until tomorrow to memorize it before you give me any sort of like, oh, that's really hard. You guys can memorize this really easily. You memorize things that are much bigger for other classes. You should be able to handle this pretty well. Why is this really nice? This is why this is really nice. If I gave you any quadratic, ax squared plus bx plus c equals 0, what can you immediately find?
So A, B, and C and
Exactly. You can find x right away. Does it take some simplifying sometimes? Sure. Like if you have the square root of 80, do you have to simplify that to like 4 root 5? Sure. But is this method a lot quicker than completing the square? What method did we use to prove this? No, we just used what method? We just used completing the square to prove this. So every time you use the quadratic formula, what method are you really using? Completing the square. Like the shortcut version for completing the square. The shortcut version. Now, there's a special name for this thing right here. Anybody know what that thing is called? It begins with a D. Anybody know discriminant? Has anybody seen that before?
Yes.
That piece is really important because it dictates some of the possible answers. So let's just try using it and see if you can figure out why that discriminant's important, but let's more just to use it. So let's say I gave you 2x squared plus 6x minus 3 equals 0. You look at that and you say, hey, let's try factoring it. Is it factorable nicely? What do you think? If the answer isn't immediately yes, your answer should be no. So we're going to use the quadratic formula. What do you think the first thing you should do if you're going to use the quadratic formula is? Yes, please label A, B, and C. The easiest, the most common mistakes on using the quadratic formula are really simple, like mixing up A, B, and C or forgetting negatives. So Hannah, can you tell me what's A equal on this one? What's B? And C would be? -3. What's a really common thing people are? C is 3. Answer won't be correct. Now, when you plug all you're doing now is you're plugging in those numbers. You're taking these numbers right here and you're plugging them in right there. Should you just plug them in and simplify? You could, but I want to give you the most efficient method possible. Where do you think you should plug in the numbers first? True. Overall, they should go where they're supposed to be plugged in, but what was that thing I circled and put in red? Do the discriminant first. What's b squared minus 4ac equal to here? 6 squared minus 4 times 2 times, so what does that equal?
36
plus 24. So what's that equal? 60. So what is x going to equal here? Negative. What's b? Negative plus or minus the square root of all over 2 times 2. You're not quite, that right there is the answer, but is it simplified?
No.
No. You have x is equal to negative 6 plus or minus the square root of 60 all over. Are you done yet?
No.
What can be simplified there?
60.
Yeah, the square root of 60. It's going to be, you take the 4, so it's going to be plus or minus 2 root 15. And then 6, 2, and 4 turns into negative 3 plus or minus the square root of 15 all over what? 2. This would be your final answer right there. Is that a lot better than completing the square from the beginning? Again, the easiest mistakes are super easy to make. Forgetting a negative, what happens? Boom. Labeling it ABC wrong. Boom. Nate, yes?
Did you get 2?
3. What's the B value?
Negative 2.
And C? And what did I say to find first? The discriminant, which is b squared minus 4ac. So it's going to be negative 2 squared minus 4 times 3 times 5. So what's negative 2 times negative 2? 4 minus what?
I did 15 times negative 1.
That's fine. So what is that?
45. No.
60. So what's 4 minus 60?
56. Negative 56.
So now I know x is equal to negative b. So what's negative b in this case? Negative 2 plus or minus the square root of what?
Negative
56 all over what? 2 times 3 is what? So that is an answer, but is it simplified?
Nope.
So what do we have here? 2 plus or minus the square root of negative 56 all over. Still not simplified. That's going to be 2 plus or minus 56. If you want to break down that radical, it's negative 56. So what should you pull out first? So it's I root 56 all over 6. Remember, imaginary, we did that for a while. Remember? But 56, what is 56? 2 and 28, right? So that's 2 and, so yeah, this turns into 2 plus or minus 2I root all over. But the 2, 2, and 6 are all even, so what does it turn into? 1 plus or minus I root 14 all over 3.
Yeah.
Remember, we did this many times. The square root of negative 9 is I root 9. The square root of negative 100 is I root 100. The square root of negative a is what? I root a. Because what is I? The square root of negative 1. Do you remember this? We did this. What is I squared? Well, that's the square root of negative 1 times the square root of negative 1, which is what? Careful, which is what? Negative 1. The square root of a table times the square root of a table is what? A table. We did this. Remember we did this before? I know it's a while ago, so it's hard to remember. But here's the deal. This method that we used right here, in the red right there, tons of work? Not really. If you do it carefully and with focus, is it pretty straightforward? Think about this. Our answer right here, is that a rational number? That's an irrational, imaginary number. Did the work change? No, it was the same work. It was the same work.
Are we gonna have to like solve some of them like all the way?
Yes, just like we did right there? Absolutely. Yeah. So how about one with a real answer? No, a real answer is better than what we just did. You want an imaginary one again? How about this? 2x squared minus 2x plus 7 equals 0. Try that one. This one. B. I'll put in parentheses. And C is? Nice. So the discriminant was b squared minus 4ac. So that's going to be negative 2 squared minus 4 times 2 times what? So that's going to be 4 minus what? What's 8 times 7? Did I give you another imaginary one?
Yeah.
Sorry. I'm sorry. I'm sorry. No, I'm totally sorry. I meant to make it minus 7. I'm totally sorry. Again, does it change? But hold on. Does it change the work?
Isn't b negative 2?
Sort of.
Yeah, b is negative 2.
Yeah.
That's why it's right there. B is negative 2.
Oh, okay.
Okay. So now it's x equals negative b, so it's going to be negative 2 plus or minus the square root of what? all over 2 times 2. Yeah. Now, again, does the work change? No. Sorry, it wasn't real. I'm totally my fault. Square root of what? I root 52 all over 4. Does 52 break down into anything? 226, and then what is that? 2 and 13. So what does this turn into? 2 plus or minus 2I root 13 all over. But 2, 2, and 4, what does that turn into? 1 plus I root 13 all over. Yep. Did the work change even though it's imaginary? No. Work is the same. I'm sorry, I meant to write minus 7. But,
Wouldn't it be I plus 1?
oh yes, it's plus or minus, sorry. 1 plus or minus.